Thanks for joining us for this month's webinar on Waterjet maintenance. As usual, if you have any questions, please feel free to type those into the question box on the right-hand side of the GoToWebinar window, and we'll answer those at the end. If we don't have time to get to your question, we'll follow up with you after the webinar. For first-time Waterjet buyers, the maintenance aspect of Waterjet cutting can be a little bit intimidating at first. After all, we have a machine with high-pressure water and abrasive, creating an environment where the machine's essentially trying to destroy itself. While the maintenance aspects of Waterjet can be a little bit more intensive than other machines, once you dig into it, you'll find that most of the maintenance is really pretty easy. For first-time Waterjet buyers, the two most frequent questions we get are, how fast can it cut and how much does it cost? Both of these questions can be answered using Hypertherm's online Waterjet calculator. Choose your pump size, nozzle orifice combination, material and thickness, and it'll show you estimated speed depending on how smooth of an edge you want. And then over here, it'll also show you estimated hourly operating costs and cost per inch. In general, we estimate around $35 per hour to run a single-headed Waterjet, with about half of that being abrasive. Now let's take a look at what makes up the other half of that operating cost. Any prices that I mention are in US dollars and are subject to change. First, we'll start at the cutting head and we'll work our way back towards the pump. Whenever you're going to be doing a maintenance on the machine, you want to make sure you follow your proper lockout tagout procedures. I've got my pump locked out, tagged out, and then as an extra level of safety, always a good idea to close any hand valves on the system like this one here that we've got right at the cutting head. So once that's closed, you can go ahead and start working on the cutting head. So always a good idea when you're going to be working on cutting head or anything on the machine, have some sort of material, be it a bin. Here I got some foam down, catch any little parts that might fall, keep those from falling into the tank. So take out the cutting head. We've got a 1 inch and a 13/16 wrench. And on this cutting head here, we've got our abrasive inlet. It's got a little nut that screws on here. Just want to be careful when you're taking this one off. There's this little O-ring here. So just want to make sure that that doesn't fall into the tank. And you can just take that off and set that aside. So we're going to take off this lower portion here. So I can just basically loosen it up and then thread it off from there. So now we'll take this over to the bench and take this apart. Here we've got our cutting head. Always a good idea when you're working on any of these components, try to do a nice clean surface. Obviously you want to try to keep abrasive, any other dirt from getting inside of any of these things. Starting at the bottom, we've got our abrasive nozzle, which can get anywhere from 40 to 80 hours, depending on the types of tolerances that you're trying to hold. Nozzle costs anywhere from $80 to $85. It's made of a very brittle carbide material, so just want to be very careful with it that you don't drop it. Since it is a very hard material, once this nozzle does wear, we never throw these out. We'll set them aside. If we're ever cutting tube or something like that, we can put them inside the tube and they make for a nice jet deflector. So to remove the nozzle, this is just hand tight. Loosen that up, take that off. And then we have some blue goop on here. So blue goop is used on any stainless to stainless fitting to keep it from seizing. We prefer the blue goop versus the clear anti-seize, so it's visible that there is the anti-seize on there versus the clear one. It can be a question of whether it's been applied or not. Inside the nozzle nut, there's a collet that holds the nozzle in the nut. So just want to be careful when you're taking this apart that this doesn't end up in the tank or somewhere. So this nozzle, opening on the nozzle is typically either 30 thou or 40 thou, depending on the size pump that you're using or the number of cutting heads that you're using. And when you're putting this together, basic tip would be put the collet on And then when you put this in, push this all the way up against the mixing chamber that we'll see here in a bit. So push until it stops, and then take your nozzle and push this up and thread it on. So next up we've got our orifice. So above the orifice you've got 60,000 psi water pressure. Below the orifice you've got a stream of water going 2,000 miles an hour, and that creates a suction or Venturi effect inside the mixing chamber here that sucks the abrasive into the mixing chamber, into the stream, and then you get your obviously abrasive water jet stream coming out the bottom there. So for the orifice, you can typically just tip that over, maybe tap it a couple times, and that should come out. Orifice can be made out of different materials. It could be either ruby, sapphire, or diamond. Rubies can last anywhere from 0 to 20 hours, and they cost around $18. Sapphires can last 0 to 40 hours, cost around $22. Diamonds cost around $425, but when used in conjunction with a final filter that we'll see here, they're guaranteed to last at least 600 hours. So you can put a diamond into the cutting head and not have to worry about it for several months. This is particularly important if you're cutting with multiple cutting heads and you don't want to deal with rubies or sapphires failing at random intervals. You'll also get better stream quality with the diamond. And then also inside of the cutting head, there's the mixing chamber where that water and the abrasive do mix together. So I've got a little set screw here that holds that in place. Mixing chamber generally going to last around 250 hours. And when that hole on the top there grows to be about a little bit over 2 millimeters or 90 thousandths of an inch, then time to change this. And mixing chamber costs about $170. So again, we've got a little bit of our anti-seize on here. And then that might tap out, or you may have to just push it out from the bottom. So this would be the top, that's the bottom. Got inlet for the abrasive on the side there. And then on the other side, you've got this flat here. So when you put this back together, set screw should set against that flat, and then the set screw should be below the surface of the body, and that indicates that the mixing chamber would be in the proper orientation. So you do go to put this back together to get the positioning of the mixing chamber right in the vertical position. You can take your orifice, put that in. And then you'll basically push the mixing chamber up against that. So we've got our set screw position there. So hold it in this orientation. Small hole will be at the top. And then we've got our flat there. So you can position like that and then push it in. And then you'll feel when it stops against the bottom of the mixing chamber. And then we can put our set screw back in there. And as you can see, the set screw is well below the surface there, so that indicates to me that that's in the proper orientation. When we put this back on the cutting head, we'll check the flow of abrasive and make sure that that's flowing well. So now we can put our nozzle back in there. And slide that on. Push that up against the bottom of the mixing chamber. And then the nut. And then our O-ring. So let's go ahead and put this back on and check to make sure we got good abrasive flow. So we'll go ahead and put the cutting head back on here. Again, always want to make sure you have good coating of the blue goop on any of these stainless to stainless fittings. So we'll just put a little bit on there. And then we can go ahead and thread the cutting head back on. And then when it's getting towards the end of the thread there, just want to position it so that that abrasive inlet's pointing up towards your mini hopper. And then for the final tightening here, we've got a torque wrench set at maximum 45 foot-pounds. And we'll just tighten that down. And then always remember on your torque wrench, you always want to set that back to 0 when you're done with it. And then we're going to go through a little procedure to bleed air out of the cutting head. Anytime that you open up your cutting head, anytime you take off high pressure line, you want to go through this procedure to bleed any air out of the lines. There's always the risk that if you don't do this, you might damage your orifice very quickly. If you just put the pump in high pressure and there's air inside that cutting head, you can quickly damage your orifice. So we'll go ahead and do that procedure. So I'm zooming in here on the cutting head. Right here we have a weep hole. If our connection isn't tight enough, we'll get a little bit of water coming out of there, and then that'll indicate that we need to tighten that up a little bit. So on all of our high pressure fittings, we have those different connections. There'll be these little weep holes, and if you get any leaking, then just indicates you need to tighten things up a little bit. So at the controller, we press the water manual button, which puts a little bit of air into the actuator, which will then allow the needle that we'll see here in a little bit to lift up so water can go through the cutting head. And then we'll put the pump into low pressure and turn it on. So here we are at about 10,000, 12,000 PSI. So you can let that run for a moment. You can toggle the water on and off a couple times. And then with the cutting head open, you want to go up to high pressure. And then once we're up at high pressure, we'll want to make sure that we don't have any leaks. So that looks good. Now we can go ahead and close the cutting head. So now we can put our abrasive line back on here. Basically push this on here until it seats the bottom. And thread the nut on there with the O-ring. Attach it at the bottom of our mini hopper. Make sure we got good orientation of our anti-backflow device here. This anti-backflow device, normally I have blue covers on here to protect this. Like to have it off for these videos, see what's under there. So the idea with this is if you get water backing up here, the water can escape out here before making its way all the way up into the mini hopper. So now we'll just run water and then some abrasive. And abrasive appears to be flowing well, so we should be good to go now with that. And then when I turn off my cutting head, I always like to turn the abrasive button off, let it run water for a couple seconds, and then turn the water off. Okay, next up from the cutting head, we'll take a look at the needle and seat. Needle and seat's up in this area here. We'll see this here in a moment. Little needle gets forced against the seat by this actuator up here. In here there's some strong springs. It's normally a closed actuator, so if there's no air applied to this, those springs are exerting all their force on that needle, pushing it against that seat, with the idea that if the pump's on, you've got no water going through the cutting head, and then when you're ready to cut, air is applied to this actuator, and then that needle can lift. You need basically air applied to the actuator and about 8 to 10,000 psi of water pressure for it to lift that needle off the seat, and then your water goes through to your cutting head. Symptom of when you need to replace your needle and seat is when the pump is on and you're not cutting. If you have water dripping from your nozzle, then that's an indication that the needle and seat need to be repaired. Pretty easy process to repair this. Probably a good time for me to point out that Hypotherm has a nice app on the Play Store for things like this. You can look up Hypotherm Waterjet Assistant and get different style pumps that they supply parts for. I'll look under the high precision, and they've got how-to guides on things like we're about to do here, needle and seat and seal replacements on pumps and everything. Nice step-by-step guides, got some pictures and everything. You can download the PDF if you don't want to look at it on your phone. So quite a helpful app that Hypotherm has available. So I'm just going to go ahead and take this abrasive line off again that I just put on, but that's okay. So again, watch out for that little O-ring. We'll set that aside again. My pump is locked out, my hand valve is closed. Key thing on this repair, when you're taking it apart, putting it back together, is you want to have air applied to this actuator when you first loosen up and take off the adapter here, since that needle is being forced against that seat. If you don't have air applied on there, all that pressure's on that needle and you'll score the needle and seat. Always a good habit to get into to apply that air to that actuator when you're going to take the adapter off there so you don't damage that needle and seat. Then when we put it back together, we'll apply the air again so we can then thread the adapter back on there. So I'll just go over to the controller and put some air on there, and then we'll take this off. Okay, we've got our air applied to the actuator. We've got our 3/16 wrench here. Loosen that up. Again, I've got my foam underneath here, so hopefully the little seat that's in there doesn't end up in the tank. Again, since this one may already be damaged, not a huge deal, but just want to avoid that if you can. And there's our seat. So that's there. Sometimes this will get stuck up there. May just have to put a dowel or something up there, free it up, and then we'll take that out once we get it over on the table there. So now we can go ahead and turn the air off to the actuator. So just go back to the controller, turn that off. And I can now disconnect the air line from the actuator. And then we've got a 7/8 wrench to loosen this up. This is basically a little bit tighter than hand tight. One other note while we're here on the actuator, actuators can be rebuilt over time. They're a pretty long life item. If you've only got one cutting head, you may find it's more worthwhile when this thing gets old just to buy a new one. People have multiple cutting heads, multiple machines. They may find it more effective to buy the repair kit for this, some springs in there. Other key maintenance thing on here is this little muffler, which lets the air escape so that the cutting head's not reacting quickly. This muffler may get clogged up with abrasive dust over time. Just have to take that off and blow that out. If you ever do go and try to take apart the actuator, there is a note on the bottom of it that the springs are under heavy tension, and to take proper care when you do disassemble this. caution, contents under spring force. So there's our actuator. We'll just leave that here for right now. To get the needle and the little bearing out of there, there's a dowel that's provided with the on-off valve repair kit. Just push up from underneath and push the old needle and bearing out of there. I always like to take note of the orientation of this. Maybe you want to keep it on there. When you put this together, just want to make sure that that red seal is toward the bottom when you put this back together. And then we'll just go ahead and clean this out here a little bit. So isopropyl alcohol on a rag and clean that out. So here are the parts that are included in the on-off valve repair kit. Here's my old one that I'm just going to use as a reference. So you got your little seal, needle, seat, and then bearing, and a little bit of vacuum grease. That's the 1-11328. So we'll just put the needle into that bearing first. That little point on there, so that'll be what's sitting in the seat. So just push that through there. And then the little seal. Push that onto there. And then we can apply a little bit of the vacuum grease to that. So don't need a large amount of this. And that's basically it for that, so that's pretty easy. Now we'll go ahead and reinsert this into the valve body. Now we can just go ahead and put that down, that orientation down into there. And push it down a little bit with this. Push up on that needle a little bit. So of course, make sure you got good blue goop there on that. And then we can go ahead and thread our actuator back on there. And tighten that up a little bit. Reapply, reconnect our air line. And then I'll go ahead and apply air to that actuator again. Let's take off the old seat there. I'll make sure you have a good amount of blue goop again on these threads. And we'll put the new seat on there. So they also recommend putting a little bit of blue goop on the top surface there around the seat. So now I'm going to thread this back in. And then we can tighten that up. And then similar to what we did with the cutting head, we go through the same procedure as far as with the cutting head open, starting the pump in low pressure, purge any air out of that cutting head, ramp up to high pressure, and look for any leaks. This next thing we'll take a look at is a high pressure line connection. One final thing I will note about the needle that we just replaced there, we do have a water-only version of that has a special coating on there that reduces friction. So for people doing water-only cutting with lots of on-off cycles where the needle can heat up and sometimes stick open or closed, the long life needle and seat has a special coating on that needle to reduce that friction and reduce the chance of that. So next thing up here, this high pressure line connection, I'm gonna take this off here. I talked earlier about the diamond has a guaranteed life of 600 hours if you use the final filter in there. I'll show you where that's located and how to swap out the normal bullet with the bullet that accepts the final filter. So again, pump is locked out, hand valve is closed, 5/8 wrench on here, and then a 3/4 wrench on here, and loosen that. And to give myself a little extra degree of freedom, I'm actually going to also loosen a similar nut that's up underneath the hand valve that you can't quite see, but I'll just loosen that up. That'll allow me to pivot this out of the way a little bit easier. So once that's loose, you can swing that out there. So first of all, for your high pressure lines, again, blue goop, all your high pressure fittings are going to have a reverse collar like this. Basically, you want to have 2 to 3 threads showing here. If you have too many threads showing, you won't get a good connection between this thread and this fitting here. If you don't have enough threads showing, then this face here won't sit well against the corresponding face inside there. So basically 2 to 3 threads showing on any of those high pressure lines like that. Another key thing on the high pressure lines, we supply it with this protective sheathing on here. So anytime you buy any high pressure line from Waterjet, we'll supply it with a high pressure sheathing. If the line does burst, then that helps dissipate the energy. And then we'll go ahead and take this off. This is where the bullet sits. So we'll go ahead and swap this out over on our table there. So here's what we just took off. So this is the standard bullet. And then here we've got our 12533 assembly, which includes bullets, slightly different bullet, as well as the little itty bitty thimble filter, which is meant to catch any little debris that might come down your lines there and protect that orifice. So the difference with this bullet is there's a recess there that'll accept that thimble filter. So this one's a standard one, and this is the one for the thimble filter. So basically just put that guy in there. And then we'll slide that back in there. And then we'll go ahead and put that back on the machine. So easy enough on that. Okay, we've got our copious amounts of blue goop on there. So we just thread that in. Tighten that down. And then reconnect this one. So having the other end of this high pressure line also loose helps with getting this in here square. Obviously don't want to cross thread that. And then we get towards the end here, we'll just put our other wrench on here and tighten that down. And then I'll tighten the other end. And then similar again to what we did before with the cutting head and the needle and seat, we'll just apply air to the actuator, turn on the pump in low pressure, and then ramp up to high pressure and make sure we don't have any leaks. And next up, we'll go ahead and take a look at the mini hopper. Here we've got a mini hopper. This meters your abrasive down to the cutting head. This is our standard or manual mini hopper. It's got the slider on the front here. Typically you'll set this to 1 number depending on the nozzle orifice combination that you're running, and that'll stay there. So the 1030 nozzle combination, we're typically running 3/4 pound of abrasive per minute. With the 1440 nozzle combination, we're running about 1.3, 1.4 pounds per minute. So one maintenance item would be maybe once a week, just check and calibrate, make sure that you are getting that flow rate. Other thing here is we've got breathers on the system. Got one up top here. This releases the air pressure that we apply at the bulk feed hopper that pushes the abrasive over to the mini hopper. So once we get the abrasive over the apex here, we release that pressure. It's also a breather here, and then there's a breather down here. So if you ever get a situation where abrasive's not falling into the mini hopper, even though you've got plenty of pressure over at the bulk feed hopper, you'd want to clear out this breather up here and this one, just make sure that those are clear so that the pressure can be released and the abrasive can drop down into there. The other maintenance item on this is that there's a bladder down here that controls letting the abrasive down to the cutting head. So if there's air applied to that, that bladder's inflated, the abrasive can't flow, and then when you want to cut, turn off the air, and then that bladder will deflate. Your abrasive can then get sucked down to the cutting head. Periodic maintenance would be you will need to replace that bladder. Again, that's pretty easy, and we'll walk through how to do that. First thing I'll do here is I'll release my pressure from my bulk feed hopper, and then we'll drain the abrasive out of here, take this off, and take this apart. Then depending on how yours is mounted on your machine, you'll loosen the bolts, take this off. I'll just loosen these up. And of course I've got my foam underneath me, so hopefully I don't drop these into the tank. And then we'll just disconnect that air line. Probably best for me to do that right now, actually. So since I've got the abrasive manual button on right now, there's no air on that line. Otherwise I would get air blasting out of there. So I just want to make sure you leave that abrasive manual button on for this for right now. So There we go. We'll go ahead and take this apart. Basically, your bladder's in this area back here, so we'll take that off and replace that. Okay, here we've got our mini hopper. So we're looking at the area on the back here. So you got the air fitting, so you may have to rotate that 90 degrees so you can get to that other Allen bolt there. These are 1/8 inch. And then the old bladder will be in there. Probably won't come out with this part of it. So you might be able to get it out with your finger, otherwise needle nose. Pull that out. So it's the old ones. You can see you're starting to get a little bit of wear there from the air going in there. So these are ZSP 103-1 would be a pack of 5, and currently they're $40 US. Basically slide that on there, and then you can push that in there and reassemble. And then when you're reassembling this, just make sure that that O-ring doesn't fall out and that it's seated in there properly. Otherwise, that's about it. It's a pretty bulletproof item. So let's go ahead and put it back on. After I put this fitting back to where it belongs. Now we'll go ahead and take a look at the bulk feed hopper. Here we've got one of our bulk feed hoppers. Primary maintenance on this is make sure you supply clean, dry air to this. Nothing's gonna make your day more aggravating than if you've got wet air going into your bulk feed hopper. And then when you're putting abrasive into the bulk feed hopper, you wanna make sure that you use a sharp knife to cut the bag open. Don't wanna tear the bag. You can get little pieces of paper mixed in with the abrasive, which again will cause clogs. We do put this mesh screen on the top here to filter out debris. Keep this clean on the top here if you're seeing debris building up on that. And so yeah, big thing there is just keep your abrasive clean and dry. Now we'll take a quick look at the gantry. Primary maintenance thing on the gantry is once a month to clean, inspect, and lubricate the ball screws. This machine here, we've got X, Y1, and Y2, and then however many Z carriages you have on your machine. So ball screw and then linear rail. And that's about it for the gantry, really. Here we've got the abrasive removal system, at least the external portion. We've got pipes running through the bottom of the tank. We've got a diaphragm pump on the back side we'll look at in a moment here. Water gets pumped from the tank. Abrasive settles out into the bag, and then water flows back into the tank. So obviously the bag gets full. Swap this out. Key thing with the abrasive removal system is periodically, maybe once a week, run water-only program around the perimeter of your tank, kind of push some of the abrasive that might build up around the perimeter of the tank more towards those pipes so they can suck that out of the tank there. And then we'll take a quick look at the diaphragm pump. And on the back side here is air-driven diaphragm pump. So there's the wet side and the air side. And diaphragms on those will need to be replaced periodically. A couple other important design features of the Smart Remove that I point out here. First of all, each bank of pipes that we have going through the tank. You've got a gate valve here you can close if you want to send more suction from the diaphragm pump to a certain area of the tank. You've got a connection point here for compressed air. If you need to blow out any area of the tank, you can use that in conjunction with the gate valves. And then back here we've got a filter, so this will capture any large debris that's going to get sucked through the system with the diaphragm pump. Periodically you'll need to open this up and clean out that filter. This is our Apex 65 axis head. This has an additional high pressure swivel here. This will need to either be repaired or replaced periodically, maybe once a year. And then also a big thing with the 5-axis is periodic calibration to ensure that you're getting the proper angles that you're calling out for in your program. And we'll just watch a quick little video on that here in an abridged form.
So what we'll see here is the procedure for calibrating the Apex 65 axis head. It's very important that the A and the C axes are in the proper calibration if you want to cut good 5-axis parts. This is about a 22-minute video condensed down to about 4.5 minutes that walks through the procedure. Obviously, if a customer of ours has the Apex 60 head, they'd get this video in its normal speed. So I'm just going to be quiet and let you watch this, and then after that we'll watch a video on the pump seal change. And finally, we'll take a look at pump seal change video. Again, this is an accelerated format, but if you want to watch this at its regular speed, you can go to our website, waterjet.com, and under the support area, support videos, and then right here at the top of the page, you got the video on pump seal change for what we'll be watching here, the Echelon pump, as well as the high precision version. Let's take a look at this.